Well, here let me introduce my code and also give you some brief demo of my functions. So here in the source code folder, you can see all 4 tasks in it. And for task 1, it's actually import data from the CSV file. And basically, you can see we firstly create a schema with name FIFA and also create a table named player info. And after we connect to the local database, we firstly create the schema and also the table. So all the variables, the definition of and constraints of all the variables you can see in the README file. So I will not say too much about it here. And very importantly, and here is actually you import the data from this CSV file. So when you are trying to use this .py and this Python file, you need to change it to your own path. And after you successfully import it, you will see this word like are created. So second one is for task 2. And the first one is the highest improvement. So basically the highest improvement function actually can take one positive integer input x and will actually return x many players with the highest improvement. So here, x could only be an integer, and if it is not, we will actually print invalid input and return null. If x is smaller or equal to 0, we will also print invalid input and return null. So for the SQL, you can see that after we connect to the local database, we actually selected the short name for each player, and also we define a score, by take the average of those skills and minus the variable overall as our score, and we order by the score in descendant order, and we can take the first x of the first x of the result of the query, and then we will have the result, and then we will return the first x rows of the greatest the player with greatest improvements. And the second one is the largest number player in 2021. And this function also could take a positive integer y. And if it's not, we will just return the embedded input and also return now. And if it is smaller or equal to 0, we will also return now. So the logic here is to actually count the players for each club and all those players' contracts should end in 2021. And we group by club is that we count each player for we count the number of players for each club. So we order by those count in descending order, and we can pick first y of them, and we can have a result. So we actually read out a list and containing all those y rows. And the third one, and it's actually basically the same, only the constraint here is different. And the z should be a positive integer, and also it should be greater or equal to 5. So if it's not an integer or it's smaller than 5, we will print invalid input and return now. And basically here the only differences here is that we do not need the constraint that the players contract should be end in 2021. So we take away this constraint, and we can have this logic that we actually count the number of players in each club, and we order them by the number of players, and actually in a descendant order, and we can limit z of them, and we have our result. I'm going to talk about the popular nation position. So in the popular nation position part, we can find that this function does not need any input. And for logic, we can find that we select the nation position, and we actually ordered by the count of the player for each nation position. And we add a Dunst rank of them, and so that if we have like 2 nation position, and they are all actually the most popular one. Like they all have like 500 players, and by using dense rank, and we are constrained on the dense rank equals to 1, we can actually output all 2 of the initial position instead of one, instead of one of them. So here's the logic. We are basically ordering the number of the player for each nation position by descending order, and we are trying to return all the nation position with the dense rank equals to 1. And then it's actually the popular team position, and you can see it's basically identical to the previous popular nation position, since we only changed the nation to team and all logic are stay the same. So we will skip it. And the next one is popular nationality. And the nationality here is that, and we basically select, it's actually still the same comparing with the previous 2 functions. And the only difference is that the nationality could be now. So we add a constraint that it actually should not be now. So basically we can use the same logic to have the answer. So I think that's out of our task 2. Oh, yeah, it's out of our task 2. So for task 3, it's actually a unit test for all of the functions in task 2. So you can see at first there are all the functions that in task 2. I just copy and paste them in this Python file, and yeah, from here is my unit test. You can see here's the happy path test of the highest improvement function. So in the happy path, I usually add some very, very normal input like 1, 7, and 10. They are all normal input. So we are testing them whether they have the correct answer, or maybe whether they have the correct length and also the correct answer. So if not, it means that something wrong with it. And the set path here is to test some edge case like 0, -1, and some input which might not be integer, and they all should be null. If they are not, it means there's something happened, in the function. And basically, and we are also test the largest sum player 221 this function using this similar way. Well, the only thing change here is that the result of the functions are different, and basically the logic of them are the same. And here is the happy path, and here is the sad path. We are still using this hinge condition like -1, 0, and sad to test whether our function is like robust. And here is actually the same. Only difference is just this result. And oh, here is the large large number player, this function, the set path of it. And here the hinge condition is 1, since that, and the constraint is that the input should be lower than 5, should be greater or equal to 5 instead of like greater or equal to 0. And the rest of 3 functions, they do not need any input. So I did not divide the test into set path test and also happy path test. So here's only some basic test. Is that the result is equals to sub or not, or is it the length equals to 1 or not, since we only want the most popular nation position. And so in this case, the length should be 1. So here's the test, and those 3 tests, they're actually the same. And to test this result, and it's a very easy one. And after task 3, we can find that in task 5. And task 5 is actually the visualization of 3 tasks. of three results. So the first one is the highest value. And here actually define a function named highest value. And the highest value function is actually to find the top 5 players with greatest value EUR, this variable. So we simply just order by this variable in descending order and limit 5. So we can have our result. And this plot highest value function is to visualize the result in this function. So I use the value and name. There are two lists to take the return value of the previous function, highest value. The value function is actually the value EUR of the top 5 players, and the name is the name. It's actually the short name of them. So I use the Seaborn like package and use the bar plot, and I add some title and also add some name of the x-axis and y-axis, and I show the show the plot. And the second one is the highest improvement, and this function is identical to the highest improvement in task 2, so I will not say too much about it. And then in a similar way, we actually use value and name to take the return result from the previous function, and we also still use the bar plot and x name, y the value, and the value here is actually the it's the score I defined here. It's the how much did they improve, and also the title and the axis, and so and in the end I show the plot. And the last one is highest player tries, and it's basically a more difficult one since the variable player tries is not an integer. It is basically a string with all the player tries, and they are like divided by a comma. So basically we can define this number of player tries by this function. Is I actually use the length of the player tries, and I minus the length of the player tries, which I actually replaced every comma into a blank string, and I add 1, and it is basically actually the length, the number of the player tries for each player. So I ordered by this new variable in descending order, and we take the rank, which is lower than 10. Yeah, we are using the rank instead of this rank. It's because of for example, if we have the largest one should have rank 1, and the second and third one, they have the same value, and they should have rank 2. And if we are using dense rank, like the fourth one, the rank should be 3. And if we are using the rank, the fourth one, actually it should be 4. So by using the rank here, we can basically since the this task actually constrain that if there are more than 10 players, I should visualize all of them. And if we have player 9, 10, 11, they have same number of player tries, and we should actually visualize all of them. So because of this, I use the rank. Yeah. So basically, and here is the plot, the visualization method of this function previously, and I still use the value and name as a tool list to take the result from the previous function. And I actually expanded the figure since we actually have 38 of the players in our plot, and the figure is not large enough. So basically, rest of them are the same, and I rotated the axis since it will be too dense if I do not rotate it. Yeah. So I think that's all of our code. And then basically we can have some demo to like check the result. Let's see. Yeah. Well, yeah, here. So firstly, I need to navigate to the task 2 in the source code folder. So where is task 2? Yeah. And then the first one, I will use this highest improvement Python file, and you can see the result if I, yeah. So for each demo, the input, the default input is actually 10. So you can see here is basically 10 rows of the return, and it's the 10 player with the highest improvement. And secondly, I will see the largest number of players, 2021 here. Yeah, here is also like 10 output. You can see it is the top 10 clubs with the greatest number of the players. You know, all those players have the contract end in 2021. And then if we take away this constraint, it will be the largest number of the player in each club. Here. So you can see here is all the clubs. Here is top 10 clubs that contains the greatest number of the players. And you can see all of them contains 33 players in each club. And then should be popular nation position. So the result tells us that the popular nation position is actually sub. And since the task tell us to return only the most popular nation position, so here the return is only one row. Yeah, one row. And then it should be like popular team position. Yeah. And we find from the result, we can see that the popular team position is actually R, and still the sub is also the sub. Yeah. And then we can see nationality. Yeah. So we can see the most popular nationality among all the players is actually England. That, you know, everybody in England maybe they just like soccer. And then let's go to task 3. We need to navigate to the folder first. Where is the figure here? And we can use the pad test to test the result. As you can see, all the rows actually passed the test. And let's actually check the coverage of the test here. And then we want to like output the result in the HTML file. Yeah. So basically the HTML file is here, and you can open it, and you can see we have 0 missing and 0 excluded, and all the stuff in this, you know, in all those functions are actually covered. So I think it is a good result. And then is to check the result of the visualization. We first navigate to task 5, and we then try to, where is, yeah, highest value. So here is our result. You can see here is the top 5 players with the highest value. And you can also find this plot in the result folder in the GitHub. And also the second one should be highest improvement. And you can see here is the 10% with the highest improvement among among the year. And here's the weird thing is that improvement, they are actually all negative, but maybe it's because of the definition of the score. So here's the result. And then is the final one. The final task is, yeah, plot player tries. It's actually a huge plot. Yeah. And you can see here's all 38 players with kind of like greatest number of tries. And only one of them have 8 and 4 of them have 7. And basically 33 of them have 6. So like, I guess it's nearly all of my presentation. And for more information, basically you can find them all in the written file. I explain, how to use those projects on your computer, and also in the result folder. Here contains all the result, like screenshots or maybe some result, and you can have a look. So I think that's all, and thank you.